We begin this ARM64 Assembly video series with dev environments, starting with the Raspberry Pi 5 SBC running RaspiOS Trixie. We launch the terminal. This first environment is for real hardware. We will use GNU tools to assemble and link programs. We enlarge terminal text to improve visibility, then we list the folder contents, and finally we run nano tests. In the file, we write the global directive followed by the start label, which helps indicate the program start at runtime. Then we write the start label with a colon, and in the next line, the first instruction, we write move x0, 5 there. This instruction moves 5 to the x0 register. In next videos, we will expand on instructions, but now we are just testing. Now, we write move x8, 83, and then shift0. This makes a system call, or supervisor call, to the operating system. In our code, we separate the first instruction as an assignment action and the second and third together as the exit. We list the folder contents again and see the new file. Then we assemble with the new command as using parameter tests. Then the parameter O and the object file name, assembled without issues. Next we link with LD command with testo. It also linked without issues. Then we need to run the program with .test, a semicolon, then echo to see it. Executing with echo assistance should print 5, which is the return value we wrote to store in the X0 assembly register. Environment 2 is QEMU. We download RaspiOS from this site. Go to Software, then RaspiOS, download the Legacy Lite 64-bit. In the description is the link to this guide to run RaspiOS with QEMU. Download DTB and kernel files from repository. We leave the 3 files in a folder like RaspiOS. We list it to verify, then install Qbase and Qsystem Arch64. If you use a different distribution, equivalent packages should be used now. Extract the image using xxd command. After relisting the contents, we see the xz file was replaced by an EMG file, which is the image that QEMU needs to work. We notice the image is 2.6 gigabytes, but RaspiOS expects 4 gigabytes. We run QEMU image with the resize parameter image name and 4G. Now we run QEMU system ARC64 with needed parameters. It boots the system and a QEMU window with 4 raspberries appears. RaspiOS has no standard installer. The image loads the system. However, it does detect the first login for setup tasks. Back in the QEMU window, configuration has started in a text style format. It asks for keyboard layout. Choose yours. Then, it will ask for username and password to log into the system and to confirm it. Once entered, terminal load. Next, the QEMU window asks for login and password. We enter the credentials we just configured to log in and list files. We see there is nothing loaded, which is normal. We write the same example from before using nano tests to edit it. Next, we write the global directive, then start label, then move x0, 5 to assign the value. Now move x8, 83. Then the shift0 instruction to make the system call. We assemble the program with the as command with tests. It assembled without issues. Then we link with the LD command with testo and output to the executable file test. Now we need to run the program with point diagonal test, followed by a semicolon. Then echo with $ and question. When executing with echo assistance, it should print the value 5, which is the return value we wrote in the assembly. We have finished testing in this environment. Now we need to properly shut down the system and wait for it to finish. Now it's time for Android. From any Android phone, we can search for the UserLAnd app in Google Play. Check description. We install and wait UserL, and is an app that runs Linux environments without using root, including various distros. We run the app, see the different distributions that can be run, and also separate apps that smoothly run Linux here. We select Arch Linux and it asks us if we want to use the terminal or a desktop. We select terminal and wait for it. UserLAnd is an open source application that allows running several Linux distros like Arch Linux, Debian, and Ubuntu. At this point, the app has a rating of 4.8 stars, with more than 1 million downloads and great reviews. We see terminal. We write the same example from the previous environment, run the editor with nano tests, we write global directive. Next, we write the start label with a colon. Then we must write move x05 to assign the value 5 to register x0. Now move x883 followed by shift0 to make the system call and exit the program correctly without any errors. Then we assemble the program with GNU as command with tests and output with O and test O assembled flawlessly. Then we link with the LD command with testo and output to test. It linked well, then we run with point diagonal. We put the semicolon, then echo. When executing with echo assistance, it should print the value 5, then we exit. The fourth environment is QEMU-USER, a special version that only emulates user space, not full system. Install packages. These are ARch64, Lynch Genio Binutils, and QEMU-USER. These names are for Arch Linux, on other distros use equivalents. We run nano tests. We write the global directive followed by the start label, which helps indicate program start. Then the start label followed by a colon. And in the next line we write move x05 to assign value to register. Now we write the instruction move x883, then shift0. This makes a system call to exit and return control. After exiting, we assemble with ARM64 Linux Genio as command with tests and O file name. It assembled perfectly. Next, we link with Arch64 Linux Genio command with testo and output to test. It linked fine. Now run program. We write QEMU-USER, then point diagonal test, then semicolon and echo to print the program's return value. When executing with echo assistance, it should print the value 5, which is the return value we wrote in the assembly. The fifth environment is also QEMU-USER for Debian Ubuntu. We use MX Linux based on Debian. Install needed packages. These are Binutils, ARM64, Lynch Genio, and QEMU-USER. These names are specific for Debian Ubuntu, use equivalents on others. MX Linux just released version 25 based on Debian Trixie. We wait for install to finish, then we list files. It is clean. We run nano tests. We write the global directive followed by the start label, then start label followed by a colon. We write the instruction move x05, followed by move x883, then shift0. We save and exit to list files. Now we assemble with ARM64 Linux as command with test and O parameter. It assembled without problems. Then we link with Arch64 Linux Genio the command with test O and output to test. It linked, now we must run code. We write QEMU-USER, then point diagonal test, semicolon and echo, which should print 5, we exit and shut down. We have presented 5 development environments from real hardware to virtual environments. If you liked it, subscribe.